He stalks. Okay, 4 or 5, we're talking about exponential and logarithmic equations. Specifically, the biggest piece of 4 or 5 is if you have an exponential equation, can you solve for x? If you have a logarithmic equation, can you solve for x, or whatever the variable is? That's going to be our biggest emphasis, and what are the different techniques that we're going to use to solve for x, or whatever the variable happens to be. And then word problems. Always got to have the word problems. So the properties of logarithms, this is a very important property. If x, y, and a are all positive, of course a can't be 1, then the following is true. If x equals y, then the log base a of x is equal to log base a of y. What that is saying is if I have an equation, I can take the log of both sides, and that's legit. Just like we can multiply both sides by something. We can take the square root of both sides. We can square both sides, right? We can subtract the same number from both sides. So there's so many things. If it's an equation, if you do something to one side, if you do the exact same thing to the other, it's totally legal. We are going to solve 7 to the x power is equal to 12. And we're going to round to the nearest thousandth. I'm going to work this one twice. The first way I'm going to work this is exactly how the book shows it. And then I'm going to work it the way that I do it, the way that I see it. This is exponential, right? The variable x is located as an exponent. So by definition, it's exponential. In order to undo an exponential, I have to do the inverse of exponential. The inverse of exponential is log. Okay? Log undoes, is that right?
Yeah.
Log undoes exponential.
So hipster.
Okay? So the way the book does this is they say, okay, well, if I have 7 to the x power equals 12, I'm going to take the natural log of both sides. So the book says, okay, natural log of 7 to the x power is equal to the natural log of 12. What can I do with that x now? Put it in the front, because that's the property of logarithms. If you have an exponent on whatever you're taking the log of, that exponent comes out front. So now I have x natural log of 7 equals natural log of 12.
Wait, what's the difference between log and natural log?
They're essentially the same. Natural log is specifically base e. Okay? Any other number when we're doing log, we're going to use log. Log base 2, log base 10. The common log, we don't write the 10 down, but it's base 10. Natural log would be the same thing as writing log base e. Okay, so now I have x natural log of 7 equals natural log of 12. Natural log of 7 is just a number. You can type that in the calculator, it's going to give you an answer. So basically what I have here is a number times x is equal to natural log of 12. How do I make this number go away? Divide, no, because they're multiplied together. So this is x times the natural log of 7. So to undo multiplication, I will divide by natural log of 7. Again, natural log of 7 is just a number. But if I divide the left side by natural log of 7, I must divide the right side by natural log of 7. That gives me x is approximately equal to, because I'm off the last step now, now you can enter this in the calculator. Now you can give me an answer. I'm going to say this again. Anytime you push the log button or the natural log button, it's going to open a parenthesis. Don't forget to close it before you move on.
1. Wait, which one's the bottom one? It's the 3?
Three decimal spots.
Okay, 1.277.
Oh man, I did it wrong.
Okay? Perfect. Same problem. I need to get the x down. The x is currently an exponent on a 7, which means that base is 7. Right? What I'm going to do is, because this is base 7, I'm going to take the log base 7 of both sides. Because by definition, log base 7 of 7 is just 1. So essentially it cancels and that x comes out front. So because this is now gone, I get x equals log base 7 of 12. And can you type that in the calculator? How do you do base 7 in the calculator?
Math and then
Math.
There's A.
Math up to A, right? Or math alpha A if you have it memorized. So if you go math and up to A, press enter. You'll then type in your 7, you'll type in your 12, and your answer is exactly the same. Or if you wanted to, you could do change of base on this. Let me just throw out that other option. When I had x is equal to log base 7 of 12, that's the same thing as saying x equals log of 12, because that's the number that's higher than the 7 over log of 7. But folks, doing that is exactly the same thing as what we had over here. Right? It doesn't matter what the base is. The log of a number divided by the log of that number, regardless of what base is on this log, this is natural log, this is log base 10 or common log, we're still going to get the exact same answer. Okay? Which way is the best way?
My way.
Okay, whichever way that you remember and works well for you. What are you doing?
typing.
Okay. Questions on this problem?
On the other one, it doesn't matter if I use natural log or log, right? Oh, okay. Gotcha.
You know, I honestly think a lot of times mathematicians use natural log because it's only 2 letters as opposed to log, which is 3. Maybe they're lazy.
Wait, so natural log.
Did I ever tell you the story about my son's name, my oldest son?
No.
So when my first wife, when we were pregnant with my first child, I didn't know if it was going to be a boy or a girl. But I knew that my child's name was going to be Aaron. Boy or girl, the name was going to be Aaron. Well, okay, let me backtrack. In 3rd grade, I had Miss Thompson as a teacher. And Miss Thompson, every once in a while, she'd step out, maybe go make copies or whatever, and come back. And if the class was acting up, we'd have to get out graph paper and write our name 500 times.
For real?
Well, my name's Joe. There was a Stephanie and a Michael in class too. I felt sorry for Stephanie and Michael. You know, Joe 500 times is no big deal. So Aaron's name was going to be spelled boy, A-R-O-N. I saved him an A. And girl was A-R-A-N. But that's a true story. His name was going to be A-R-O-N because I didn't want that extra letter there in case he had a teacher that made him write his name 500 times. I was looking out for him so he could save. And now I later found out that Elvis Presley's middle name, correct spelling, is A-R-O-N. Don't know that? Sometimes you'll see it A-A-R-O-N. Huh?
I'm not obsessed like Mulkey.
Yeah. But his middle name is A-R-O-N. Okay.
I feel like that'd be pronounced Arlen.
And he wouldn't have that sub that would say A.A. Ron. You done messed up, A.A. Ron. Okay. I have an equation. It has 3 as a base on one side and 0.4 as a base on the other side. This is a mess. But in both cases, the exponent has a variable. So it's exponential on both sides. How do you get the exponents down?
Log.
You take the log of both sides. So I'm going to take the natural log of both sides. Can I skip a step and go ahead and bring the exponent out front?
Yes.
Okay, so notice my exponent is 2x minus 1. I don't want to write it like this. I don't want to say 2x minus 1 natural log of 3. Can you see why?
Because it'd be the -1 times the log.
Yeah, this just looks like 2x minus 1 times that. Because 2x minus 1 is my exponent, it must have parentheses around it. And I'll do the same thing with the right side. I'm going to pull that x plus 2 down, but because that x plus 2 is my exponent, I need to keep it as a group. I'll put it in parentheses. Natural log, wowzers. Natural log of 0.4. Okay.
Oh, I messed up. Oops.
Now, put your calculator down, dude. Pay attention. Okay, I don't want a specific answer. Be very, very general. Okay, be very general with this answer. What is the natural log of 3? What is the natural log of 0.4? Be very general with me, please.
A number.
A number. It is. It's just a number. Okay? So if I have 2x minus 1 times a number, what would you do to simplify this?
Divide.
Factor. Oh, no, not factoring.
You don't want to find natural log of 3 because it's going to be an irrational number. And when you're working logarithm problems, you want to save logs and natural logs till the very end. Otherwise, you're rounding early on, and that's going to make your answer very wrong. It's just a number times this binomial. What would work here? Distribute it. I'm going to take this natural log, which is just a number. I'm going to distribute that natural log to the 2x. I'm going to distribute that natural log to the minus 1, which gives me 2x natural log of 3 minus natural log of 3, because you have a minus 1 times natural log of 3. Okay? Equals on the right side. Same thing. I'm going to distribute the natural log of 0.4, which gives me x natural log of 0.4 plus 2 natural log of 0.4. I don't know if I'm speaking to anybody specifically in this class, but if you're one of those lazy people that doesn't write 0.4, you just write 0.4, you need to be careful. It's very easy for that decimal to disappear if you're doing that. And all of a sudden, instead of having the log of 0.4, you're now working with a log of 4, which is two totally different numbers. That make sense?
What is the decimal disappear?
Huh? You might not see that you wrote a decimal on your paper when you were writing it. Okay? And this is the first spot where students tend to really get stumped. Okay? We are giving a solution. What is that asking us to do?
An answer, an exact
An
answer.
answer. There might be more than one, but what is that asking us? Solve. What are we saying? Solve, answer. Okay. It's asking us, for this particular problem,
What is the exponent? What is x?
what is x? Right? Which means our goal is to get x by itself. That's what's going on here. What would y'all like to do with this problem? I'm trying to get x by itself.
Divide by the natural log. No, you can't do it.
Okay? When you are working a math problem, when you're trying to solve, 99% of the time, you will not divide until the very last step. What were you going to say?
Add the natural log of 3 to this
What are you trying to do? Why would you do that?
to get 2x natural log of 3 on one side, and then you can do x natural log of 4 subtracted.
Okay. Okay, so here's where we are.
I have a question.
At this point, get all terms with a variable on the same side. Before we can solve for x, we need to get every term that has an x on one side and get everything else on the other side.
Can you cancel out the natural log of 3 on the left side because I know PIMDAS, yeah, it's 2x minus 1.
No, because this natural log of 3 is being multiplied by 2x. So we have to multiply before we subtract. Okay? So I need to get all of the terms that have an x on the same side. Does it matter which side? No. Sometimes I prefer to get it on the right side, sometimes I prefer to get it on the left side. This particular problem, it doesn't matter. And so when it doesn't matter, I like to put the variable on the left side. Personal preference, if you don't like it that way, you can do it your own way. So I want all the x terms on the left side. And another thing that I'll do, and I'm gonna do this on the same time, I move the variables first,
So x
okay?
by itself.
So I want to subtract x natural log of 0.4 from both sides. So I kind of step back and look, and what's going to happen when I do that? When I do that, this is gone. So I have no more variables on the right side. On the left side, I have two terms with a variable, and I got this guy. This guy doesn't have an x, he needs to go away. So how do I make him go away?
You add natural log of 3.
Add natural log of 3. Okay, am I messing up with anybody's mind doing this in one step? Okay. Okay, these don't combine, they're all like terms. So I'll keep them both. I have 2x, natural log of 3, minus x, natural log of 0.4, is equal to, because natural log of 3 is gone. On the right side, this term is gone, but I still have this piece left. I have 2 natural log of 0.4 plus natural log of 3. And I find that many times that students are able to complete this step. This is where they get stumped. My goal is, what is x? My goal is get x by itself. There's been one topic that I've talked about first semester and this semester. And I've said many, 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 many times it is super, super important. What do you think that I've talked about as being one of the most important topics that we've covered in this class?
Factor.
Factoring.
Oh my god, it's right.
Factoring. Okay?
It's the 0.4.
So look at the left side. How many terms are on the left side?
2.
2. Do those two terms have anything in common?
No.
Yes.
X.
They both have an x. So because both of them have an x in common, I'm going to factor out that x.
There's factoring in this.
Put those two notes on the side, guys. Super, super important when you're doing this. Factoring out the x. I have 2 natural log of 3 minus natural log of 0.4. I factored it out. What is 2 natural log of 3 minus natural log of 0.4?
Do you want to see the number?
One.
Don't give me an answer,
I don't know.
Oh,
It's a number. right? I want to leave it this way. I don't want to know the value of it yet because you would be rounding right now, and I don't want you to round right now. This is a number. This is a number times x. How do I get rid of this number? Divide both sides by this number.
Does X equal? You want to do it?
Now on the left side, I put it in parentheses. The only reason I put it in parentheses is because I wanted to put emphasis on the fact that the numerator and the denominator are exactly the same, right? So anytime you divide something by itself, what do you get? 1. So on the left side, this is just 1. So I have x equals, but it's not going to equal because I can actually do the math now. We're on the very last step of this problem. So go ahead and type in the right side exactly as it appears. Remember again, every time you hit the natural log button, it's going to open a parenthesis. You must close it. It's best if you enter this as a fraction, doing alpha y equals.
Do we round to the nearest thousand?
Yeah, let's just keep going there.
Oh, okay.
You can negative number.
Yes.
Negative 0.235 or negative 2.36 is around.
And rounding, you probably get something about negative 0.236.
Wait, I'm so confused. I think I typed it in wrong. I mean, you don't have to like do complicate every time you type in the wrong.
That's 0.04. It's supposed to be 0.4. So press second enter.
Second.
And you go back and change it. All you have to do is put 0 point instead, and it should fix you. Enter.
Oh.
Okay.
Okay.
Can you do this?
Yes.
I mean,
If I can type it
eventually
in
with
right.
time of getting used to it, but it's a lot to remember to do.
That's why you write
He's gonna tell us there's gonna be some easier way.
No.
No?
No.
Darn it.
Well,
I'm so excited.
six like.
Okay. Y'all have this written down, this line right here?
Yes.
What is it?
2x
Oh, that's that
minus
video.
1. And ln 3 equals x plus 2
Parentheses.
x plus 2 ln 0.4.
Y'all okay with what I just did?
Yeah.
I guess.
He turned.
I just kind of cleaned it up a little bit,
Remove variables.
okay?
What?
Yeah.
So I'm still trying to get x by itself, right? But instead of writing natural log of 3 and natural log of 0.4 all the time, I'm going to get x by itself, and when I get to the very end, I'm going to bring the natural logs back. Okay? This would be 2ax minus a equals bx plus 2b. Is this looking easier for you?
I mean, it looks a lot cleaner.
Okay. I'm trying to get the x's together, so I'm going to subtract bx from both sides. I'm going to add a to both sides. I have 2ax minus bx, that's gone. That's gone, equals 2b plus a. I'm going to factor an x out. I have x times 2a minus b equals 2b plus a.
That negative b that you subtracted from 2ax, where did that go?
The what?
You subtracted bx
Ah.
from.
It went right where the minus
That one?
x. It went minus a.
Okay, never mind. It says
Divide both sides by 2a minus b. I get x equals 2b plus a over 2a minus 6.
Wait, minus
It's a
6.
B.
That's a b. Y'all good with that?
I thought you were trying to prove a point about the 0.4.
Okay, so now I get to this point, I could change the a's back to that and the b's back to that and then type it in the calculator. Or, yeah, I'll do it, what the heck. Y'all maybe never done this before.
No, like.
We can put it in the calculator.
Oh, wait,
yeah,
set
that
variables?
equals it, Yeah.
So I'm gonna
Yeah.
take natural log of 3, natural log of 3, close parentheses,
Stove.
and I'm going to stick that into A. So I will
Stove.
store it into
Alpha.
A. Now I'm gonna take natural log of 0.4, natural log 0.4. I'm gonna store that into B. I'm not gonna type that. 2 B plus A over 2A minus B.
I think that's better.
I like this way.
Like what?
I like this way.
What I just did?
Yeah, with the calculator.
Yeah.
Uh-oh.
The most important part if you do it this way is don't forget to store those into A and B. Otherwise, it'll think A and B are 0 if you reset your calculator, and then you're gonna have the wrong answer. Okay, let me adjust problem A real quick because it's wrong. Now we're good.
E to the x power to the second power.
E to the x squared power.
Oh. I knew that.
So e to the x squared power is 200. We're solving for x. What's e, by the way?
I don't remember the number.
A number, 2.718281828.
Take your word for it.
Okay, all right. My variable includes an exponent. I need to bring the exponent down. What do?
Add it. Wait, is add it or multiply?
Take the natural log of both sides. By taking the natural log of both sides, I can take this exponent and pull it out to the front. So I have
X squared.
x squared, natural log of e is equal to natural log of 200. What's the natural log of e?
1.
It's log base e of e is what it is, so it's 1.
Yay!
Okay, so the natural log of e is just 1. So because that's 1, I have x squared equals natural log of 200. How do I get x squared by how do I get x by itself?
Square root.
Square root of both sides. And what is important to remember about taking the square root of something?
The index.
Plus and minus.
2 answers. Okay, plus or minus. And go ahead and give me the natural log of 200.
The square root or the natural log?
2.
Take this, get the natural log of 200 and take the square root of it.
I got 2.301 or 3. 2.302.
Well, natural log of 200 is just a number. So if you just type square root,
2.302.
great job.
Oh, I remember.
Great job. Proud of you, sir.
I need to go back to the survey and change something. One of the things was the instructor treated me with fairness and respect. I am conflicted.
It depends on your perspective.
Well, it does say me. Nah, it's actually not that bad.
Okay, part B. I have e to the 2x plus 1 power times e to the negative 4x power is equal to 3e. Okay. What happens when you're multiplying when the bases are the same? What do you do with the exponents? Okay. So here we have the same base. So add the exponents.
Wait, so if they're the same, will that make it 2e? Or just keep it e?
It's still e.
Oh, okay.
We keep the base. Okay. Remember, x cubed times x to the 5th. It didn't become 2x, did it?
No, it just became x.
X to the 8th because we added them together, right?
Oh my gosh.
Okay. So here we have the same base, so we're going to keep that e.
Negative 2x.
Okay. Perfect. And we can do one more thing to clear things up. Because before you start simplifying or solving your exponential, you need to simplify what you're working with. And I can still simplify this. The e. What do you want to do?
Want to cancel it from one side?
How can I make this e go away?
Divide it by e.
But if I divide one side by e,
You gotta divide the other.
okay.
That just makes it.
What's going on the left side now?
It cancels out the e, right?
Oh,
The e doesn't cancel.
Oh.
Because it's got the exponent.
it's a negative exponent.
Okay. So when you're multiplying with the same base, you add. When you're dividing with the same base, you.
Subtract.
So I have negative 2x plus 1 minus 1.
So it'd just be negative 2x.
Negative 2x. So I have e to the negative 2x. Now it's simplified.
Now we use a log.
Now we'll take the natural log of both sides. Taking the natural log of both sides, natural log of e is 1, so it cancels. I get negative 2x equals natural log of 3. I want x by itself,
Divide by negative 2.
so x equals natural log of 3 divided by negative 2. Type that in your calculator.
Negative 0.549.
Perfect. Okay. And it took us a minute longer than first period and 2 minutes longer than fourth period. I meant second and fourth to get here. The next one, we're going to get into factoring with exponentials. But we'll stop there for now. Guys, be good for the sub tomorrow. Make sure you're working like you're supposed to.
You have a substitute?
Don't be jacking around tomorrow. You got Mr. Colin in here.
You're not even